Are you right? Okay, thanks everyone. Thanks for coming to our little session. So we're going to be talking about remote cameras at unmanned landfills. Just to give you a picture of net waste, we are a voluntary regional waste group. There are 8 of these around the state. We cover 26 councils at the current time, a third of the state, and we cover sort of Broken Hill all the way to the Blue Mountains. So it's quite a big area with around about 100, probably a bit less than 100 active landfills and transfer stations. So just to clarify what we're talking about, we're actually talking about these little remote cameras. You can see that are mounted on the pole there. We actually made sure that there's no actual power to site, so we had to make sure that there's a solar panel on there. Thanks, Tom. So there's a few reasons why we wanted to go down the path for unmanned landfills. As you can understand, all these small councils may have multiple landfills that are unmanned, and they don't often know what's going there, and they often can't monitor what's actually happening out there. So often if there's a fire out there, they'll often get a call from someone locally to say there's a fire out there. So look, one of the main reasons really is for us and for the councils to better accurately determine how much waste is going to their local landfill. And is it being on a regular basis? Is it being used on a regular basis by residents, or in some cases is it being used by contractors or potentially business operators who maybe should be using one of the licensed and manned landfills? We're also hoping that the project will help councils down the track to actually determine whether they look at closing their landfills and turning them into transfer stations, or potentially looking at a different way of managing them. So we've got 4 councils involved in this, and one of them's in the rooms, which is great. So we've got Cobar, and there were 2 sites that we've got at the moment. There's Nimmingy and Uabalong. Nimmingy, we did stick a fake camera out there, and I'll tell you the results of the fake camera at the end of our presentation. We also had 2 down in the Lascaux area, which was Portland and Wallerawang, and then 1 at Bogan Gate in the Park Shire, and then 1 at Bojerabong. So I'll pass over to Tom.
Thanks, Sam. So we got a couple of drone photos during the project, so this will give you just a bit of an idea of what the sites look like. So a lot of them are basically just your standard trench landfill in a rural setting. So this one is the one at Park Shire Council. So you had a long access road that came in, and cars would either pull up parallel to the trench and then do a U-turn as they left, or vice versa. But there was only one road coming into the tipping face, which made it quite easy to capture a lot of the cars. Lascaux had a similar setup. You can see at the top of the photo the access road winding its way down, a long trench there. Portland was one of the few sites that had some resource recovery that went on. You can see the scrap metal and the green waste pile. So the composition was a little bit more useful there. Other sites where everything goes in the trench, the composition was useful, but it couldn't really be used for a lot because everything's being landfilled. Wallerawang also on Lascaux. This one was quite a long trench. I believe it was probably about 90 or 100 metres along. So it would present quite a challenge to photograph that one. So this one we put a camera along the entrance road. And Bojerabong, this one was the smallest site in Forbes, so that was just a little trench, and you can actually see the camera in the left of the photo there. So just in terms of a timeline of when all this happened, so we went through a bit of a procurement process around September, and in October we had all the cameras installed, but we had quite a fair few bugs to work out along the way, which is kind of what we're talking about here today. So by February 2017 we kind of got everything stabilised. The cameras were connected to the internet and everything was running. So these are the cameras that we installed. The one in the middle looks a little bit ominous and a bit Big Brother-ish, but the one on the left is what we call a farm cam. So a lot of these are built from parts from China. They're assembled in Australia, so farm cam is just the name of the supplier. And the farm cam one had a 1 megapixel camera, a little solar panel, and the whole unit only weighed about 1 kilogram, so it's quite easy to find a pole to stick it on because it doesn't have a lot of weight which would blow it around. that uses an external sensor, which I'll explain on the other slide. The one in the middle was sold to us from a company called SolarCam. That one was a bit heavier because it's got a golf cart battery that runs off the solar panel. It weighs probably about 15 kilos. So the next photo across on the right is a tilt pole. So we use that so that if we have to adjust the cameras, it's easy to do, because if they're put up 4 metres and you have to get a ladder out every time, there was some safety things. So it's manufactured in Melbourne, a company called Easy Pole. So they actually did quite a good job. We think we had 4 people quote on it, and theirs was the cheapest. And it's good to have it made in Australia, because a lot of them were trying to ship it to us from overseas. So how the cameras work is, on the left, the SolarCam one. So what it is the camera divides the photo up into a series of basically rectangles, and if there's movement in a number of the rectangles, then it captures the photo. So on the left here is the trench that we have at Bogan Gate. So the cars that arrive, and we might have had it set at 16 pixels. So when there was movement in 16 of them, we took a photo of the car as it arrived, and when people moved around, we'd get photos of them unloading and see what the composition was. The farm cam used an external sensor. So this was kind of like, you know, when you walk into a house and there's those electronic little frogs that go ribbit when they sense motion. That's pretty much how the farm cam works. So it looked for a heat signature that came past, such as a car exhaust, and when that came past, triggered an infrared sensor and the photo was taken. So this gives you a bit of an idea of the view we had from the SolarCam. So this is one of the sites in Lascaux. So I blurred out the number plate, but this one has a higher megapixel, so we could easily, if we wanted to, log the number plates of the cars coming and going. So if we found a fire, or if we had a load of asbestos dumped, we could start to work backwards from a compliance perspective and find out who was using the site. This one is a view of the trench at Bogan Gate. So as you can see, aiming the camera at the trench, it can be a little bit harder to frame the cameras, which I'll talk about later, because they can essentially pull up at the far end or they can pull up short, but this one captured it quite well. And again, if you needed to see the number plate, you could capture it. This was a photo we had from the farm cam, and this one was the 1 megapixel sensor. So you wouldn't be able to see the number plate, or this camera is not so good from a compliance perspective, but the low megapixel meant the files were quite small, so the camera didn't need as much data, and it actually worked quite good in the low signal areas. So on to what we learnt, a bit of a background. So this is what we pulled together. What we did was we looked at the number of vehicles coming and going from the site, and then we used the EPA standard weights for vehicles to try and estimate what the tonnages that were coming into these sites were. Now, who's here? Is anyone here from regional landfills, or that owns regional landfills in New South Wales, manages them? Yeah, so you guys use the standard weight factors? Yeah, so, and you probably find them a little bit challenging sometimes, yeah. So that's what we were trying to use them to see if we could, turn these vehicle movements into tonnage estimates. And as you can see, we had a drone flight on the bottom row there, and that gave us a bit of an estimate of what the change in volume was in the sites. So when we used some of these EPA standard weights, 0.6 of a tonne for a car, 0.3 of a tonne for a ute or a trailer, and say 2.72 tonnes for a truck, we got these massive overestimates, by a factor of 4 sometimes. And we're kind of scratching our head and think, these factors even all that useful, because when I was chatting with Sam, he made the point, say out west, the ute is more of a standard car. People drive it. It's not necessarily full all the time. Whereas, say in Sydney, if you were arriving at a landfill, that when they introduce some of these factors, it's often a business using it. Whereas out west, it's just a family car. So the idea that every time a family car arrives at an unmanned landfill, it's carrying 300 kilos seems quite unlikely, but there's no other numbers that we had to work with. So what we did was we just assumed that all cars were 0.6 of a tonne, and then when that happened, it seemed like the numbers aligned a little bit closer to what we got from the drone estimate. So just something to dwell on. The EPA hasn't provided any other assumptions to work with at the moment, so we've just been working with what we have. The other thing to note was that using some of these cameras, if you're trying to estimate your tonnes coming in, the trucks can quite quickly skew your data if you are using the EPA weights, because 2.72 is the lightest truck you can have, and then it goes upwards from there. So if you're doing a 1 week audit, trying to if you do say 4 1-week audits during the year, you can end up with quite an overestimate on the tonnes. I'll just check if there's... and the other thing to note was a lot of this could also be estimated just with a pneumatic counter, so just those 2 black rubber things that run along the road. Some councils use them to log the vehicles coming and going, so that's another method you could use if you just wanted to count the number of vehicles coming and going from the site. The only thing is that the Ausroads data set that comes out of it can't discriminate between cars and utes. They've both got the same wheelbase under that, and you wouldn't have any photos of cars if you want to record some compliance. We had challenges early on with mobile connectivity, so a lot of these rural sites don't have the best Telstra coverage. So Sam and I, when we went out, we just had our iPhones and we're just trying to gauge how many bars there are. And we found out later on there's a more scientific method with the communications guys can come out with a wand and give us exact numbers. But when we were starting out, we looked at the bars and we found out that if there was less than 2 bars on an iPhone or a smartphone, you really needed a Yagi antenna, which is the one that's pictured on the right there. So that was at Bajerabong. So if you're at a site and you don't have any signal whatsoever, a Yagi antenna can often just raise it up enough that with a camera like the farm cam, it's only got a 1 megapixel camera, so the files are quite small. So every now and again it'll get a little bit of signal and send it out. But when we were there, the phones couldn't pick up anything. So, and at the Bogan Gate sites, the cameras there were dropping in and out, and once we had an antenna put on them, it stabilised a lot. So especially with the camera that was in the middle, the solar cam, when you're using some of these cameras, when the signals drop, they can go through a bit of a reset procedure, so you lose about 20 minutes, which means that you miss a lot of cars. I also forgot to mention that we had, I think, 4 people provide prices on cameras. So the farm cam and solar cam were about $2,000 a pop, which is why we tried them on a few sites. Some of the other prices we got were for more of the RMS spec kind of ones, so they were $7,000 and $11,000. So it wasn't really affordable to trial them at multiple sites. But there is various manufacturers out there, and there may be other ones that we didn't hear from or we couldn't find. So when we're positioning the camera, we had a few things to think about. The advantages on the access road were that we'd be able to capture every vehicle that came into the site. When you're down at the trench, you might have cars pulling off early for green waste or for scrap metal, and you wouldn't be able to capture them. But the disadvantage of, say, having it on an access road is that often the vehicles come through it, pretty quick relative to the speed we'd like them for with the camera. Whereas in the trench, the vehicles are stationary, so they're pulled up, they've stopped, and they're unloading. So it's a perfect way to frame the photo. Whereas on the access road, if they're speeding past, often you'll just have a photo of an empty piece of road because they've shot through. The other disadvantage of the access road is that councils generally want to encourage people to cover their load, so they want to use tarps and make sure there's no windblown litter generated. But if everyone's arriving with covered loads, you don't really have an idea of the composition. So this gives you an idea now. Yeah, it's actually pretty legible up there. So we had a pneumatic counter put in at Wallerawang just to get a bit of an idea of what the vehicles were and what kind of speeds they were going at. And on the left here you can see this was a really rainy day, so on the top left is actually water over the road, and you can see how many more cars were captured when the vehicles were going slower. And on the right is a sunny day 2 days before, and you can see how many empty photos there were of the road, because either they were shooting out or they were shooting in. And when I looked at it, about 70% of the vehicles that were using this site were going faster than 20 k's an hour from the pneumatic counter data. So this is even with a cattle grid and a speed hump. So if you could get them a little bit slower, speed hump, or I don't know what other methods we could use, but because we're approaching the end of the trial, so we can't exactly do it now. But yeah, if you're trying these cameras, ideally you want to put cameras on a bend, or just maybe with coming around a bend just with a speed hump after that, or just anything to get them going a little bit slower. In terms of the analysis, so an example for Bogan Gate and Bogerabong, both of those sites had around 60 vehicles a week using them. So to log on to the website portals that the camera people provide us, download the photos and go through everything, it was around about 4 hours of staff time. So it's not all that much when you think about if you're doing the audit in person. So this is for the New South Wales councils. If you're doing send out someone for a week to basically audit all the cars coming and going, you could do a similar thing with only 4 hours of staff time. So it doesn't take all that long to get through the photos. Now, if you had a bigger site, or the site like Lascaux, it's a little bit harder, but for your standard unmanned landfill, it seems pretty cost effective. But on the subject of Lascaux, so Lascaux was the site where compliance was the biggest factor, and Damon there really pushed it. So Portland and Wallerawang were a bit closer to built up areas than the other two sites, and as a result they had a lot of trucks and commercial waste that were using their site. In fact, I don't have the sequence of photos here, but there was a photo of a semi-trailer coming in, and then quickly, about 30 seconds later, he'd obviously chucked a U-turn and left the site once he realised he'd been photographed. And then he went to the main waste depot in Lascaux and spent $1,500 to get rid of his load. So, that's a pretty sizable chunk of money that paid off the camera. And Damon, I think during the trial, he probably sent out about 30 show cause notices to different commercial people who'd been using the site, because Lascaux landfill's now got a weighbridge and they charge money, whereas these village ones are free, with the caveat that commercial people shouldn't use it. But obviously they find it quite enticing. So on one of the sites, which was Bogan Gate, we used 2 cameras just to see how it works. So one was at the access road and the other one was at tip face. And we found that worked quite well, because we could cross-check all the cars coming and going against each other. If one of the cameras dropped out, the other one generally was up and running, so we wouldn't be missing any photos. And it seemed to work quite well. It was a bit more expensive because you have 2 cameras on the site, but then you weren't left wondering if you were missing cars, because they tended to catch everything. We also went and did a drone survey. So this was just to cross-check. Have we got time? Yeah. This was just to cross-check against some of our estimations, which is the figures that I showed you on that early table. We had a guy give us quite a good rate for this, so we got it for about $500 a site, which we did a bit of a milk run for the 4 sites. So that's pretty cheap when you think that 2 solar cams, once you factor in buying a pole and setting them all up, it's around 16 flights worth, and the drone can give you quite a good volume estimate. So that is a cheaper option. The only thing is you just miss out on the compliance aspect, because you're only there for 4 days out of the year, whereas the cameras, if you're wanting to track trucks coming and going or have a log of when there's a fire, you'll have records for the site. And this is some of the further work that can be taken up on the topic of using some of these remote cameras. So we'll find out how long they'll last for. Sam will tell the story what happened out at Cobar. We've got some site-specific standard tonnages for vehicles. With maybe, the EPA, you could get a bit of funding, or we could figure out a way where you could spend a week auditing the vehicles coming and going at some of these sites, and maybe find out that the standard vehicle is 0.1 of a tonne, and then you can use that as for the next few years as your standard vehicle weight when you're logging movements. There might be some alternate detection. There's companies that provide radar detection, kind of like your speed cameras. I imagine they'd be quite reliable, but no one's making them in a format that can be used with solar panels at the moment. So something like that might come online, and that feeds into, there might be some new camera technology that comes out, which means that there could be some better detection for a cheaper price, but we won't know until it's released.
So I'll just end with the story with Cobar. So Cobar was concerned with obviously with the cost. So what they very cleverly decided to do was to trial a dummy camera, and the dummy camera was shot. So it was shot, and the pole was removed. So it's now supporting a pull fence out at Nimingi. So it's put to good use. But that was one of the main concerns from all of our councils, was about them being vandalised, and we've only had one, and lucky it was only the $5 cheap China camera. So thanks very much.